We now move on to the last presentation of the day, which will be held by two presenters, Ms. Ute Katranski and Dr. Heiner Hild. As we've already seen before, there are many users here of Canoe in this auditorium, and I would guess that many users of vTESTstudio and vT are also in the auditorium, and I'm sure that they are definitely interested in what's new in these fields and what new things can be expected in the near future. And we will learn that from Mrs. Katranski and Dr. Hild. Most of you will know her. Nevertheless, I want to briefly introduce them. Ute Katranski studied mathematics at the University of Applied Sciences in Stuttgart. Since 2006, she's been working at the department Tools for Networks and Distributed Systems at Vector Informatik. First, she worked as software developer in the field of network design tools and standard file format editors. Since 2009, she's been working in the domain of testing with Canoe, and by now she is product manager for the test design tool vTESTstudio. And let me introduce Dr. Hild at the same time now. He is team leader and product manager for the VT system at Vector Informatik, and he's responsible for the development of the VT system and other I/O test hardware. Mr. Hild studied physics at the University of Stuttgart and received a doctorate in image processing. He worked for over 10 years in automotive development on driver assistance systems, and he's been with Vector since 2014. Mrs. Katranski, you have the floor. Thank you. Let me welcome you to the last presentation of today. We want to give a brief overview of what's new at vTESTstudio and Canoe, VT, and what's the outlook? Where does the journey take us? Talking about news for vTESTstudio and Canoe, I'm talking about TESTstudio 2.0 and Canoe 10.0. So I wanted to mention at this point that freshly in the market, still warm, but now I'm saying it's still in the oven, but hopefully we are going to take it out later this week. So what can you expect? We've got a new graphical editor, in addition to the one with which you can graphically model test sequences. So we want to offer a new graphic modeling language with which you are not graphically modeling the test cases as such, but you're describing the expected behavior of the test specimen as a state diagram. And we take this state diagram and generate it from that automated test cases. So we do it in the following way. So we reach a full transition coverage. We ensure that with the volume of test cases that we generate from that, at least each transition is covered at least once. As a first step, there will be two algorithms for that. For once, we've got the Chinese postman on offer, and then a breadth search-based algorithm, which means that if we take a look at this state diagram, then these 5 test cases would fall out there. That's breadth search-based algorithm. It's rather several short test cases. With a Chinese postman, it would then preferably be one longer one. Let's take a look at one. The title of the test case states exactly what kind of transitions have been covered. That's the test case. I initialize my system, check that the light is off, turn the light on, check whether it's on. Then I put the ambient light above a certain threshold. I check that the light goes out automatically. And in that way, after that, I've got a cleanup, and thus we create test cases in order to test the transition and the state cases. So if you've got a test specimen or a part of a test specimen, which can be described through this kind of a state automat, then you can easily get your test cases and you can conduct reviews nicely on this level as to what is actually being tested. Next topic, that's our Canoe test report viewer. Today we are generated XML and HTML reports, nice and good. But at some points we are reaching our limits, which is why we want to make a changeover, saying that we will no longer write XML, but we are going for a database. We are writing SQL database, and we are giving you a nice tool with which you can take the data apart. So, which means, for example, doesn't work, but doesn't matter. So we've got filters, for example. Nowadays, prior to Canoe, you have to decide what you want to see afterwards, which is sometimes difficult. If you're saying you're only interested in the failed test steps, and it would be interesting to note what happened before that. And so in the future, we put everything in that we know, and afterwards, you can dynamically switch the filter on and say, show me failed test steps. Conditions are of no interest, so blank out the pumps and so on. You can also have various views displays on the data. So the classical test execution tree that you know from Canoe. Then you've got the opportunity of saying, show me the test cases sorted according to verdict, or show me all linked trace items, that is requirements, how were they tested, through the linked test cases in each case, which requirement was tested, pass or failed. So you've got very many options there to have different views of the data. So we've got a few predefined ones, but you can also compile random queries there on your own. One example, you're interested in all test cases with failed cycle time checks. Then you just formulate accordingly. You formulate your query, and what you get is an appropriate list of test cases, which means that you have got an opportunity of comfortably and powerfully analyzing the data. Mr. Dodek, you can see if in the future you run your tests with vTESTstudio, you will get a super report and you can see immediately what was failed in the Canoe configuration generation. Then traceability as our next topic. We've got the connection with the JAWS Next Generation Rational Quality Manager. We've had that for some time already. What's new in the portfolio is the connection with Siemens Polarion Elm and PTC Integrity. I can cover this rather quickly. It looks always the same. Anybody who attended last year will already know that picture. On the left-hand side, you've got your TDM system. You define requirements or test case specifics. You import them as so-called trace items into vTESTstudio, link them with test case implementations, play with the traceability matrix, the information via implemented test cases and requirements and requirement links. You play that back into the TDM, and after execution in Canoe, then you attach the results, and thus you get the full traceability from requirement to test execution result in the TDM. This is supported by so-called connection utility, which is a standalone application that takes over this connection. You can then freely download it for free at the Vector homepage. On to a topic which basically we have already sufficiently seen or answered. We've already seen it live. The colleague summarized it for Mr. Meyer's question. How could Vector Cast interact with Canoe and vTESTstudio? Here briefly, schematically, as an overview of how we can and could bring these two toolboards together. I've got my ECU code, instrument source code. I send it through the Vector Cast. It will be instrumented. I then load it down to my embedded system. On this, as usual, I then run my test cases, which I created with vTESTstudio. And in the background, the code coverage is being set up which can be analyzed then accordingly in vector cast, and the appropriate evaluations will be made available, and based on that also change-based testing can be implemented and realized. So that was a brief extract from the new features. Of course, there are many more than that, but time doesn't permit me to tell you everything. And once again, very soon you can take a look at it on your own for yourself. Now, a brief outlook. What are we busy working on? Where do we want to go? First topic, test case attributes. We want to give you the opportunity of taking random metadata and to define them as test cases, be it, for example, for lifecycle management or as an indication of the ASIL relevance of a test case. So to each test case, for example, you can say that's got lifecycle in implementation reviewed, just any attributes that you define and hand out to the test cases, which we write into our Exchange formats, and then you can play them back into the test data management system in order to have access to the information. In order to make it possible to still handle it in the vTESTstudio, together with these test case attributes, there is a new view that we're offering, a test case view or overview, where you can nicely see all the test cases that you have with their attributes. And for a number of test cases, you can then also switch over these attributes all at once. And as you know it from the traceability metrics, you've got the opportunity of going from the overview and navigate into all of the other elements. Then we want to pimp the waveform editor still a little bit. At the moment, you can define stimulation curves with it, but frequently you've got the case where, quite fitting with stimulation, you wish to make certain tests and reviews. If you've got a stimulation curve simulating ambient light, for example, then I want to say here at the top, when my ambient light it has been over a certain threshold for a certain amount of time, then the automatic light control should be switched off. And in the future, right here, directly in this graphic, I can place a checkpoint and say, please check at this point that light is off. Here at the bottom, I would test that the light has automatically gone on. And here again, maybe additionally to the light state, I would want to check whether after the end of the stimulation and the synchronized check, the fault memory is still empty. So nothing like I start the curve and I have to start some wait commands at the same time in order to know when to begin my test, but directly in the graphic, in the diagram at this place, you can then accordingly define your checks. And then last but not least, navigation into test design, which means that you've got your wonderful test design, for example, in the test table editor. And then, for example, there is the one who executes the tests in Canoe and wonders, what's happening if I execute the test case crash detection, what's behind it? Today, he has to take the name or whatever, and then in test design, painstakingly search for it. In the future, he just simply says, please open the appropriate test design and show me this test case. So a simple option now to get to the right place, navigate to the right place in the test design. Or other use case, you've got an audit. Auditor says everything is nice about traceability. You say you've got a test case locked with increasing velocity. Now show me where it actually is. And you are saying, well, of course, no problem. Look there. And of course, then very clearly for analysis, you've got a report here. There's something there. VT command has failed. What has gone wrong? Is it due to the test specimen or the test design? In the future, you simply say jump there and take a look as to whether everything is correct there in the test design. So that much in terms of my outlook. And this now brings us in our navigation right to the VT system. And I would like to hand over to my colleague. I didn't mean to say that test cases always fail with the VT system. That must have been due to the test specimen, I'm sure. Thank you, Ute. So I have the last part of the presentation block. The topic similarly is in VT, what are the new features that we added in the past year? What can you expect in the foreseeable future? With the first topic, I want to go back a little bit. You will remember the first presentation after the keynote was about e-bike testing from the colleague from Bosch. He still had an SPI sensor with an external device connected to his test environment. And this is exactly the topic that kept us busy for the main part past year. Apart from analog sensors that we can already connect with the VT modules, how can we then also connect digital sensors that are becoming all the more widespread in the environment? SPI is one example, but there are other sensor protocols and application cases of powertrain safety comfort, but also many other areas. This motivated us to then baptize the sensor option, which can be found in Canoe, but also in the appropriate VT module. The focus and the goal was quite clearly in the way in which we already know Canoe to expand it to sensor protocols, sensor protocol communication to be tested and analyzed and stimulated, and that in the usual environment that you already know from Canoe. Ultimately, there are two classes of protocols. We call the ones automotive sensor protocols, C5, and SENT is included, C5 predominantly for airbag, SENT for engine control and other domains. And apart from these protocols with a genuine protocol spec with a real frame structure, there is what we call microcontroller based ones like SPI on the future, maybe also UART, I2C or LVDS. That's the address room for the sensor option. The target quite clearly is that in the future we want to integrate those protocols in Canoe, and SENT is already in series, and SPI also comes there now with the release 10. In terms of the configuration concept, it's the way in which you know it from Canoe. We have to say that the sensor channels, they are somehow biased between genuine network protocols and IOs. That's why we gave an intuitive GUI for them. So let me illustrate it. Taking the example of C5, the idea is the same. You select a channel there from the ribbon item. In that case, you connect an ECU and one or several sensors, and per sensor, then you can configure time slots without mentioning details of the protocol systems. There's a fourth level here, graphical dialogues with which you can configure that. They are then nicely highlighted there also with tooltips. The point there is, how long will a time slot take? In that adjustment field, you set the slot length. What do you do? How is it reflected in the frame structure? The target being that the sensor bus should be configured in the same way in which it is ultimately operated. That's just as true for SENT and SPI. The other protocols, sending out the protocols, but in terms of look and feel, it's the same. The analysis concept puts the core onto the data structures provided by Canoe, system variable structures in concrete. So the use data and the frame data of the individual protocols are taken over into the data structure that already exists. The benefit is quite clear. So we can easily build upon what Canoe already can do. All of the analysis, Windows trace window, and the other window logging replay can be done in the same way as you know it for the network protocols. That's a technical solution. Here an example. So in C5 example now once again, which takes over the option that is dissolving the protocol frame, interpreting in the trace window, and showing it there, or the individual data, be it the signal or the accompanying data like frame length. They can also be mapped in the graphics window. And once again, within the time basis that Canoe has anyway, with an exact correlation with the other I/O events or with other network signals. And in the automation, it is available just as much as the other data structures. All of this does have to be taken into the world, and from the world into Canoe, back into Canoe. For that, we've got VT2710 as a module. We call it the serial interface module. It's two-stage. There's a basic module. The basic module covers... Can you still hear me? Yeah? The basic module covers the protocols like SPI in the future UART, to 1I2C and to LVDS, and optionally, as shown here, at up to 4 spots you can add piggies that serve C5 and send. The solution is because the switches there for C5 and send are more sophisticated, and for those customers who only want SPI, we didn't want to expect them to also acquire that. So anybody who needs only simple protocols can take the basic module with 2 channels each, and anybody who wants to use C5 or send can have up to 4 channels equipped with piggy boards, and thus the more complex protocols can also be run. Operation modes, as would be expected from a test system, are possible either way. We can simulate sensors, like for example an airbag sensor. So Canoe makes the use data available, the option and the board converted into the appropriate electrical system with a fitting timing, and they play it into the bus. Or in the other case, the ECU is being simulated, example SPI. That's done by the master simulation. The module makes the clock available, calls the chip selects as required by the bus that can be configured, and these sensors in this operating modus are operated really. You can also do man in the middle, only listening in. Then you have 2 channels are required. Future topic is active probes, but I would like to skip that now. So you can see on the right hand an idea of what it looks like. The module is also in series with the Canoe Release 10. Apart from the already available C5 and send, SPI will be added additionally. Then a second topic. So when it comes to real-time modules, we also did additional things. We've got 2 real-time modules for the VT system on offer. Originally, we had the 6010, the smaller one, which is suitable for up to 2 network interfaces or 8 bus channels. We replaced it through VT6011, a more powerful processor in that case, Intel Celeron. And at the upper end of the RT modules, we've originally had the 6050A or 6051. We replaced it through 6051A, which has now got an Intel Core i7, so really computing power. So as the predecessors, it's for maximum 4 network interface modules, respectively 16 bus channels. So that's what it's suitable for. But what's new compared to the predecessor is that the 6051A also supports Canoe ERT, so extended real-time functionality of Canoe can be activated on that module. And in concrete terms for VT, this brings the advantage, we mentioned it several times before today, that apart from the previously known time constraint of 1 millisecond cycle time per system variable, you can now, for selected ones, as shown here for the measuring parameters, you can also have 500 microseconds or 200 microseconds having that available. That's added with the IT module. Of course, it's quite clear. The bus width doesn't get bigger, so you have to be economical there. But where higher update times are required, this is a new option, which in the past was people were asking for time and again. So those very briefly were the main topics that we covered in the past year. Now we take a look forward into the future. The VT system, at the beginning it was mentioned that Mr. Brinkmeyer was one of the fathers of the VT system. I would say by now the VT system is a young adult. You can see it here from the structure also, as being shown here. In various areas, we've got quite many modules. I don't want to elaborate on any details. Quite a few modules already being on offer, and direct ECU interface top right, or support functionalities that go in the direction of a test system or indirectly towards the test specimen. We've got them on offer. Then we've got infrastructure modules like the backplanes, the housings, power supplies, and network interfaces, the 2710 or the candle and FlexRay interfaces already now on offer. And one might say that's great. We're basically through with it. But of course we aren't. The world of testing keeps on developing. And here again, we still have gaps that we successively are filling. And we like to do that in a dialogue with you. In the medium term, we also want to include all new things. The system is growing. I said it's a young adult, a juvenile. So there's still potential, both in terms of size and width. There's enough growing space. So in system modules, currently we can imagine a switch matrix. So for direct ECU interface, so 48 volt grids, hybrid grids, higher currents or higher I/O speeds are an issue where we've got gaps. For infrastructure, it's quite clear you can never get enough PC power. That's also true here. IT modules can be upgraded all the time. We will do that. And here again, more data throughput, high speed, more network channels. What would be thinkable in the medium term is a topic that was also mentioned today, the image processing solution with which HMI elements can graphically or by video also be analyzed. And last but not least, on the network topic, there is Ethernet at the top, but also further serial buses. Other gaps that we are still seeing that we are going to fill one after the other. And the things that I'm mentioning now, they're already being developed in the course of the year. They will be available as a series. Switch matrix module, we have thought what complements the system in a meaningful way. That's a model with which higher currents in the matrix can be switched. The module will be designed in such a way that it's going to be 8x4 matrix being offering. So per path, 20 amps can be freely routed, up to 20 amps can be freely routed. And so we will have test band switches that can be implemented freely. You can also bundle channels if the 20 amps are not sufficient, because we are using semiconductor technology for the nodes and no longer classical relays. So you can nicely switch them in parallel, and with reduction of the switching path, you can increase the current volume. That's quite interesting. Another aspect that we cannot yet serve, but with this we will be able to serve it, that is bouncing contacts, simulating them. So, bouncing contacts. So, because we are using these semiconductor switching elements, we will certainly get above 10 kilohertz, where the appropriate performance can be switched on and out in order to simulate switching and bouncing contacts. So, from the asymptotic API, that's one of the features in the AES port that we cannot serve at the moment, but with this module, we will be able to serve it. Last but not least, 8x4 elements. If they are not enough, it's also possible to take several all together, to switch them together in order to build several matrices together. Already mentioned the second topic, 48 volt vehicle power support. We see a need for ECU supply, but also taking over power from the ECU. So the two modules, 7001 for the ECU supply, power supply, and 1004, 1004A for the ECU output. We will modify them accordingly so that they are capable for 60 volt. So if we want to test 48 vehicle power nets, you have to go up to the 60 volt limit in order to safely then address over voltage. At those two ends, there will be new modules that are 60 volts suitable, and due to the higher voltage, then will be equipped with semiconductor switching elements. Third topic, I think it came up time and again, that's rotation encoder. Time and again there is a question. The speed sensor signals, can we simulate them? We can already do that today with the FPGA boards. But we've got an application board in the making with which we offer it in a pre-implemented state. It will be able in the first stage to take the classical wheel speed sensors with the different types, S, I, and V type. Anybody who knows it will recognize the images. To make them available preset, they will be used in such a way Canoe from a model or a setting makes a wheel frequency setting or varies that setting, and the sensor produces the appropriate digital signal as a voltage or current modulated signal. There are both types available at this point. That's the first step. In terms of the module, it has already been developed but not yet released. In terms of electronics and the setup, it offers additional options. So simulating crankshaft and camshaft sensors, or then analog and digital sensors that we cannot yet cover with the sensor option, to use those, or to also offer a use case where digital signals with a certain disturbance can be treated. The basic underlying idea of the model then is to issue high voltage with a very high frequency, and then being able to offer a free curve. So first the wheel speed sensors, then voltage or current modulated, and the other steps will then continuously be added. Then Ethernet testing was mentioned several times before today. We already have network interfaces on offer. There will also be one for the VT system, which in terms of functionalities will use the 5640 basically as an orientation, which is already in the market as an external Ethernet interface, but the channel number will be reduced practically in half. For the automotive Ethernet channels, we will have the module 6 there, where we have some in the 5640, and for the general purpose Ethernet channels, 1 gigabit, 1000 base P, we will have 2 channels where the 5640 has got 4. There will be no CAN, because for CAN we're having a separate module. So that fits very nicely into the VT. Additionally, the module, apart from the external network interface, will have VT and test typical options and opportunities of scattering in faults, as you know it from the 6204 fault injection. In the first instance, automotive broader reach, relay short circuit against ground, or offering that on the relay basis. Technical implementation will be in such a way that the automotive Ethernet interface will be implemented there on the PIGI board. So if you change the automotive Ethernet protocol, then you can exchange the PIGI and retain the basic module. Last point that goes beyond VT, but I still wanted to mention it, e-mobility testing. There are very many facets of it. Today, several times we heard about it. Apart from the VT7870 with the charge, with which you can test charge communication, we've got a test setup that we developed with which battery management systems can be tested. That's an aspect. VT does have a role to play here, because the battery management unit, the device under test, has got classical IOs that are served by the VT, but for the test of a battery management system, cell voltage simulators are required, which dynamically then map the real battery behavior and simulate cell voltage. And we've got a setup now where there is a simulation model in Canoe that we can run as a MATLAB Simulink model in real-time dynamism, with the appropriate outputs, the IOs being served with VT, and we can control it from Canoe, as shown in the diagram on the right-hand side. There are a few data on performance. So the first experiment showed that a system, a simulation model with 108 cells in smaller than half a millisecond can be executed. And so a millisecond takt was required, so we can safely comply with the simulations there. I think that's an interesting use case for people who are testing battery management systems. That was my little outlook. I hope you were able to take something home with you. And afterwards, I will be available for more discussions if you've got suggestions or questions. Thank you so far. Mr. Hild, Mrs. Katranski, thank you so much. I think we were able to get an impression that the machines are running at full speed, talking about new components that are being produced and trying to fill any gaps that may be existing. But maybe you stay here, the two of you, Mr. Hild, Mrs. Katranski. I'm sure that there will be questions, I would want to believe. If that's not the case at the moment, then let me ask you, Mr. Hild, this topic of reducing the cycle times from 1 millisecond to 500 microseconds and 200 microseconds. Well, I think many people will like that. You can always use something like that well. Can you give us a feel for how many channels, by way of an example, can be put down to 200 microseconds until the bus says, now it goes no further? Well, it's not easy to answer that question, but in terms of a guide value, we keep saying that between 100 and 150,000 events per second. And so you can make your calculation what to do that. If you're saying one channel with 200 microseconds, then it's 50,000 events per second. And this is how you can try to be economical about it. No, I'm sorry, 5,000. So I was just thinking, double thinking. So that's the rule of thumb that you can take for your calculation as to how much you can afford. Okay. When it comes to Mrs. Katranski's topic, her presentation, I would be interested to know the following. The Canoe test report viewer is part of Canoe, so all of the users of Canoe can benefit from it? Yeah, that's the case. The Canoe test report viewer is part of the Canoe installation, but it is also freely available. So anybody, any man, any woman can download it from our website. So this kind of a report, an SQLite file, you can also pass it on to a colleague who's got neither Canoe nor a vTESTstudio license, and even that person can fully benefit from the features offered through that of the report viewer. And the other thing that you presented with synchronized checks, that's of course also very interesting. Is that also a pure Canoe topic? Or can these types of tests now only be defined with vTESTstudio? Well, ultimately, we've always got the combination vTESTstudio for test design and Canoe for test execution. And the feature, the screenshot that we've seen, that was the part that runs in vTESTstudio, where you define the test design, and it will then be executed in Canoe. So you always need Canoe for test execution. Oh yeah, I realize that. That's quite clear. But my question is, can you then, mind you, have it in XML or CAPL? Can you run this check or define this check in XML or CAPL so that other test definition platforms can also use it? So you mean the way in which you can define the check? Well, we have seen on the screenshot it was a simple check command, but you can take just any CAPL definition, CAPL function that tests something more complex. So at a checkpoint, at a test point, random test commands or test implementations can be played, can be connected. Okay, anybody else? Let me ask you, the audience, any questions? So I believe our listeners might be a little bit exhausted. So we say thank you very much once again to our two presenters.